Now what we can do is we can put this all together to see what happens in the case where both the observer and the source are moving. Now once again, Joe explains this very well. So let's cut back to Joe's explanation of what happens when we put it all together.
Finally, if both observer and source are moving, the two factors both apply, and so the expression is this one. Remember the sign convention, positive if approaching, negative if going away.
So you've seen that for the case where the observer, in this case pictured as the man on the bike, is approaching the source, which is the ambulance in this case, we can work out the frequency observed by the observer using the formula, the f dash is equal to f times v plus vo, all divided by v minus vs. In all these equations, the VO stands for the velocity of the observer and the VS stands for the velocity of the source. Now, in the case that the source is approaching the observer but the observer is moving away from the source, so for example in a chase type situation, we would have the equation F dash is equal to F times V minus VO, all divided by V minus VS. Now in the case where both the observer and the source were moving away, we'd have F dash is equal to F times V minus VO divided by V plus Vs. And the final case is where the source is moving away from the observer but the observer's moving towards the source, so the observer's trying to catch up to the source. In that case, the equation is F dash is equal to F times V plus VO, all divided by V plus Vs. So basically, if you remember the standard equation, F dash is equal to F V plus V naught divided by V minus Vs, that describes the case when both the observer and the source are approaching each other. If one of them's moving away, then you just need to change the sign in front of that term. So if the observer starts to move away, just switch the sign in front of the VO term. If the source moves away, just switch the sign in front of the source term. If they both move away, switch the sign in front of both terms. Okay, let's use this to solve a problem now.
So the question is, as you ride your bike at a speed of 40 kilometers per hour, a police car with its siren screeching at a frequency of 700 Hz comes up behind you with a speed of 70 kilometers per hour. What frequency do you detect? The speed of sound in air is 343 meters per second. So let's start by sketching a diagram. Here's you, the observer, and here's the police car. The police car's behind you and it's approaching you. This is the source and you're moving away from the police car. So this is the situation we have. So we're going to have to use the equation F dash is equal to F times, now you're moving away from the source, so that's V minus V of the observer, and the source is approaching the observer, so that's V minus Vs. So now all we need to do is work out what each of these terms is. The velocity of the observer is 40 kilometers per hour, which is equal to 40 times 1000 over 60 times 60, which is equal to 11.11 meters per second. The velocity of the source is 70 kilometers an hour, so 70 times 1000 over 60 times 60, which is equal to 19.44 meters per second. So we have that this is equal to 700 times 343 minus 11.11 over 343 minus 19.44. And solving this on the calculator, we end up with 718 Hertz. Now what you could do is you could extend the question and say, well, what would happen once the police car had overtaken you, and can you work out the frequency then? So how about you have a go at that on your own?